Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on December 5th, 2025, about a week ago. It proposes a training time trick that lets large vision language action models control robots smoothly in real time, matching or beating past real-time chunking methods, while eliminating the extra computation they needed during inference. The paper is titled, Training Time Action Conditioning for Efficient Real-Time Chunking. And, as we will see later, the implications for fast, low-cost robot control are pretty significant. Alright, the previous intro set up the goal of making robot control both smooth and cheap. Figure 2 shows how training time conditioning gets wired into the diffusion transformer action expert. The bottom bar encodes past actions in red and future actions in beige, and only the future actions are noised. The middle block runs these tokens with different flow-matching time steps, where prefixes get a time step of 1 and postfixes get a learnable delay. The top bar then applies loss only on the green postfix outputs, so the model learns to respect the fixed prefix while denoising the rest of the trajectory. While Figure 2 explained how the model handles prefixes internally, Figure 1 clarifies what those prefixes look like along the time axis. The full bar shows two overlapping action chunks, with the left block as the previous chunk and the right block as the current chunk. The pale red segment marks actions already committed from the previous chunk. The red and yellow segment marks the overlapping window that inference time chunking inpaints. The green blocks mark fresh future actions that extend the trajectory beyond the overlap. Alright, the previous figure focused on timing along the trajectory, and Figure 4 shifts to the real robot tasks that stress these timing decisions. The left image shows a dual-arm robot folding and assembling a cardboard box, which needs long, coordinated motions with precise alignment. The right image shows a robot preparing espresso, where the gripper moves toward a portafilter of ground coffee, capturing the fine manipulation required for grinding, tamping, extracting, and pouring under real-time latency. Well, the previous images showed what the robot does. Figure 3 shows how often it actually succeeds as latency grows. The vertical axis reports solve rate, and the horizontal axis shows inference delay and time steps. The blue curve for training time, real-time chunking stays highest, especially once delay reaches 2 or more. The green curve for inference time, real-time chunking drops faster, and the red naive async baseline collapses most sharply, which highlights how crucial action conditioning really is under slow inference. Alright, the previous plot highlighted simulation trends, and Figure 5 confirms that pattern on real robots. The left column shows success rate, where training time, real-time chunking in blue beats both inference time chunking in green and synchronous control in red on espresso making and box building. The right column shows duration, and both real-time chunking methods finish faster than synchronous control. Training time chunking, therefore, preserves success while cutting wall clock execution time. So the story's pretty simple. Training time action conditioning keeps robot control smooth even under real latency, while dropping all the extra in-painting compute at deployment. That shift makes fast, capable vision language action control feel much more practical for real robots. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.